Today we are starting our probability unit and we are going to talk about sample space. So the sample space describes all of the possible outcomes of an event, and then sample space can be displayed with lists, tables, and tree diagrams. So those are the three things that we're going to do today. And really, lists and tables are going to go together. Sample space can be displayed with lists, tables, or tree diagrams to determine the probability of simple or compound events. Okay, so let's look at number one. Number one says the New England Patriots and the Dallas Cowboys are playing. What are the possible outcomes of this game? So the possible outcomes of this game is that either the Patriots win or the Cowboys win. Number two, a number cube is rolled, also known as a dice. Yes. What are the possible outcomes? So if I roll a die, my possible outcomes is that I roll a 1, 2, 3, 4, 5, or a 6. Okay. And moving on to the next one. Number 3. So number 3 says that for breakfast, Jamie can choose between cereal, eggs, or a muffin. And she can also drink coffee, orange juice, or milk. What are all the possible outcomes and how many total outcomes are possible? Okay, so for our food, let's look at our food. We could have cereal, eggs, or muffins. So if I choose cereal, we're going to make a table. So I wrote cereal down. And if I choose cereal, I could choose a coffee to drink, an orange juice to drink, or a milk. So let's say I chose coffee. Okay, but also if I chose cereal, I'm going to write cereal down again. I could have chosen orange juice. So I'm going to write orange juice down, or orange J. And then if I chose cereal, I could also have picked milk to drink. So even if I picked cereal, I have 3 more choices, 3 more options to choose from. Okay. And then same thing if I chose eggs. What if I chose eggs for my food and not cereal? Then that means I have those same possible outcomes for my drinks, right? So I have eggs, but I could have drank coffee, orange juice, and milk. Okay, does this make sense? So then if I chose the muffin, I could have coffee. If I chose the muffin, I could have orange juice. And if I chose the muffin, I could have milk. So how many possible outcomes is this? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possible outcomes. Okay, so how can I do that faster than counting each possible outcome that I wrote down in a list? I have 3 options for my food times 3 options for my drink. Gives me 9. Okay, so let's do that again. At registration, a student can select from Spanish or German class. So I'm either going to do Spanish or German. And then my next selection, so that's my language class, as well as art, music, or theater. What are the possible outcomes and how many total outcomes? Okay, so for my language, I have 2 languages that I can pick. I can pick Spanish or I can pick German. Okay, so let's talk about Spanish. If I chose Spanish, I could either also go into art. If I chose Spanish, I could go into music. And if I chose Spanish, I could go into theater. Okay? But what if I didn't pick Spanish? What if I picked German? I could also go into art. If I pick German, I could also go into music. And if I picked German, I could also go into theater. Okay, so how many total outcomes are there? Well, there were 2 options for language multiplied by 3 options for arts. Arts meaning art, music, or theater. So how many possible outcomes? There are 6 possible outcomes. And yes, write the word possible, please. 6 possible outcomes. Okay, let's go to number 5. So number 5 says a fair coin is tossed 3 times. What are the possible outcomes and how many total possible outcomes are there? So this, we're doing a tree diagram, okay? So it says that a fair coin is tossed 3 times. This means I'm going to have 3 tiers. Okay, so I flipped the coin once. What are my possible outcomes? Heads or tails. Okay, so that was my first flip, so that's 1 tier. Then I'm going to go into a second tier. So let's say for my first tier, for my first flip, I landed on heads. Okay, so then now I've landed on heads. I'm going to flip again. What are my possible outcomes for my second flip? Heads or tails. So I landed on heads the first time. I landed on heads the second time. Then that means from here, I'm going to flip a third time. And I landed on heads. I landed on heads. What are the 2 other outcomes for the third flip? Heads or tails. Okay. So what if I landed on heads, but then I landed on tails for my second flip? Well, then for my third flip, what are my possible outcomes? Heads or tails. But what if I didn't land on heads the first time? What if I landed on tails the first time? So then from here, I would flip the second time. And what is my possible outcomes? Heads or tails. So what if I landed on tails and then I landed on heads? Now I got to flip a third time, right? And I can land on heads or tails. Or I landed on tails and then I landed on tails. Now I have to flip a third time and I could land on heads or tails. Okay, so how many possible outcomes are there? Well, I flip a coin once and I have 2 possible outcomes. I flip the coin again and I have 2 more possible outcomes. And then I flip the coin again and I have 2 possible outcomes. So 2 times 2 is 4 and 4 times 2 is 8 possible outcomes. Okay. Number 6. Amanda will roll a number cube and flip a coin. So we've got a number cube going on. We got a flipping of a coin going on. If Amanda rolls the number cube once, so we're only rolling once, and flips the coin once. What are the possible outcomes in which the number cube lands on an odd number? So I'm only rolling the number cube once. What are my odd possible outcomes? Well, a number cube goes 1 through 6. So my odd possible outcomes is a 1, a 3, and a 5. And notice I left space there because I did that on purpose. So let's say I rolled a 1 and now I need to flip a coin. What are my possible outcomes for flipping a coin? My possible outcomes for flipping a coin is that I landed on a 1 and I landed on heads. But also, I could land on a 1 and also land on tails. But what if I didn't land on 1? What if I landed on 3? Then I could flip the coin and land on heads. And I can roll a 3 and flip the coin and land on tails. Or I could have rolled a 5 and landed on heads. And then rolled a 5 and landed on tails. Not and then. Or rolled a 5 and landed on tails. Okay, so what are how many possible outcomes? I didn't have to do that, but we can see that there are 6 possible outcomes here. Okay, so the 2 spinners below are spun at the same time. What are the possible outcomes of the 2 spins? And so our directions say to create a list. Okay, so what are our possible outcomes on the first spinner? Okay, so if I'm right here, I spin it, what are my possible outcomes? I could land on a 1 or a 2, correct? So let's say I landed on a 1 or a 2. Okay, so after I do this spinner, then I come over here and I'm going to land on a color, right? So if I landed on a 1, I could land on yellow. Or I could have landed on red or orange or blue. So how many times do I have to write the number 1 down? I have 4 possible colors, so I need to write it 4 times, along with the number 2. Okay, so go ahead and press pause and finish this one out, and then press play when you have finished. Okay, so this is what yours should have looked at like, and so you would have a total of 8 possible outcomes. 2 times 4 equals 8. POs for possible outcomes. Okay, so number 8 says that a clothing line has shirts in red, blue, or white, and it has pants in gray or khaki. It wants us to create a tree diagram. Okay, so what are my possible shirts here? We're going to do what's called branches for each possible color shirt. Possible color shirt is that I could have done red, blue, or white. Okay, so let's say I chose a red shirt. What are my possible pants? My possible pants are gray and khaki. But what if I chose blue? What are my possible paint colors? Still gray or khaki. And white is still gray or khaki. Okay. Okay, so here, how many different combinations? Well, I had 3 options for a shirt multiplied by 2 pant options, which equals a total of 6 possible outcomes. Okay, and it says, how would adding a green shirt to the clothing line change the tree diagram above? Well, if we added a shirt, that means that we would add we would have to add a branch, right? And if we add a branch, that's going to add more possibilities. So that means that I would have had 4 shirts multiplied by 2 pant options, which equals 8 possibilities. When buying a car, Esther can choose a 2-door car or a 4-door car, and then it could have leather or cloth, and then the interior colors can be black, silver, or white. Okay, so the first thing that you are selecting is a 2-door car versus a 4-door car. Okay, so let's start with our 2-door car. If I chose a 2-door car, now I'm choosing between leather and cloth. So I have 2 options, leather and cloth. Okay, so then once I choose leather or cloth, I have my colors. So let's say I do a 2-door car with leather interior, then I can choose between black, silver, or white. or a two-door car with cloth, I still can choose between black, silver, and white. But what if I didn't do the two-door car? What if I did the four-door car? I have leather and cloth, and then my colors. Okay, and so how many different options? You had 2 choices for the car, 2 choices for interior, and 3 choices for your colors. 2 times 2 is 4, and 4 times 2 is 12. Okay, I want you to be on your